whenever you're working these problems, so number 14 on 9-1, you got to get rid of that exponent that's outside the parentheses. So I'm going to leave this guy alone, 10s cubed t, and then what's negative 2 to the third power? Negative 8. That's negative 2 times negative 2 times negative 2, which is negative 8. And then, if s squared is being raised to the third power, what do you do with those exponents? Multiply them, and you get your 6. And then t to the 6th. All right, so I get this simplified one step. Now, I'm going to multiply, since that's all that's going on now, 10 times negative 8, negative 80. What's s cubed times s to the 6th? S to the 9th. So you added those exponents. T to the, because t to the 1st times t to the 6th is t to the 7th. And that's your simplification. By the way, when you simplify, you have to get rid of all parentheses. You can only have one of each variable. And what kind of exponents can you have? What kind of exponents? Positive only. So that meets all the criteria. Okay, 9-2, number 13. So this is now we throw in division and how you deal with those. So number 13 on 9-2. Okay, you can keep working. On these problems, my first step is to get rid of those exponents outside the parentheses, and I'm going to do that in the numerator and the denominator. All right, so I get in the numerator j to the 8th, k to the 12th, and L, I'll put a little tail on that, to the 4th. In the denominator, I get j to the negative 1st, k to the negative 4th. Okay. So you got rid of parentheses, but is this simplified? No. Two reasons why it's not simplified. One reason is, Jack.
There is still division.
Yeah, you would say that there's still the same kind of like terms, but the same base multiple times. And then secondly, it's not simplified because you have negative exponents, so that can't be simplified for two reasons. All right, so what I'm going to do is I'm going to combine the bases. Really, that's your first step. Combine those bases, and then you can make sure they're positive. So if j to the 8th is being divided by j to the negative 1st, what do you do with the exponents? You
add or
subtract, good, which is going to become 8 minus negative 1, which is 8 plus 1. You get j to the 9th. By the way, whatever you get when you divide j or k on the next one, you put it in the numerator, whether it was a positive number or a negative number. Okay, I'm going to combine the k's, k to the 12th divided by k to the negative 4th, 12 minus negative 4, k to the 16th, and then the L stayed the same in the numerator. Do I have to move anything? No. No, because all the exponents are positive and there are no more similar bases. Okay. 9-3, number 10. 9-3, number 10. This gives people trouble. How do they want me to express my answers in 9-3? Express each number in scientific notation. I don't want standard form. I just want scientific notation on number 10. Mr. A, it already is in scientific notation. Is it? something wrong with it. So you have to correct it. And in correcting it, things will have to change. Okay, if you're looking at this, you're like, okay, I know the decimal point is right here, and it needs to go right here. That's 3 times. Okay, and then this is where people get confused. You're either going to get 6.480 times 10 to the negative 5th, or you're going to get 6.48 times 10 to the 1st. Which one is it? It can't be both. Okay, it is 6.48 times 10 to the 1st, but why? Because I guess it's a 50-50 which one it is. Yep, Brian?
Because 648 or 6,480 is a big number.
Good, okay. This is what I'm doing when I work this problem out. Because I remember, I've taught this for many years now. I used to say, all right, if you move the decimal to the left, you make the exponent go up. If you move it to the right, make it go down. But if you're going from standard to scientific notation, you actually have to go backwards with that. So I'm like, they have to remember backwards and all that. I'm going to make it easy on us. This 6480, the original number, was that big or small? Big. It was big. So I know I got to change it to 6.48. I think all of us are good with that. If I change this, just this number right here, just look at this number by itself, wouldn't it be 6.48 times 10 to the 3rd? Wouldn't that, just right here, turn into that? And then I have times 10 to the negative 2nd. So what's 3 plus negative 2? 1. So that makes it so much easier because I just break the number in front into scientific notation, and then I add that last power of 10, add those bases, add those exponents. That's my answer. It's fail-proof, which is nice, isn't it, for a test? Okay, anyway, just be careful. 9-3, number 18. How do I want your answer written? In scientific and standard. Yes, sir?
Yeah, there is.
Look further down. Okay, so you multiply the 2.2 and the 3.2, and you should get 7.04. So that's your number here in front. Times 10 to the? Why third? Yes?
Because since you're multiplying, you have to add negative 2 and 5.
Good. These two are being multiplied, so you add those exponents and you get to the third, and that's your scientific notation. And then, if it's in proper scientific notation, you can write it into standard very quickly. Is this a big or a small number? Big, because it has a positive exponent. So I know, where do I move that decimal place? To the right or to the left? 1, 2, 3. I move it to the right because that's the only way I'm going to get a big number, which is what it said it was. 7,040 for standard form. Yes, sir?
What if it was like 10 to 0? Would that be a big or small number?
That's kind of like, yeah, it's the same number as what you had. So, like if this were 7.04 times 10 to the 0, you could say it's a big number because it's above 1. If it were 0.04 by itself times 10 to the 0, small number. It's kind of like a neutral place to be. But then you have to change it into scientific notations. Okay. Let's go to 9-4. And I'm going to actually have you do 2 problems. please read the instructions because they'll tell you what to do. Numbers 3 and 9 on 9-4. Numbers 3 and 9. And please read the instructions so that you know what they're asking for. All right, I'm going to go in the order that they gave in their instructions. So it says first, state whether each expression is a polynomial. So, Matt, is number 3 a polynomial? Yes or no? No. Why not? Good. It has a variable in the denominator right there. It's not a polynomial. Number 9, is it a polynomial, Emery? Is 9 a polynomial? Final answer. Give me your final answer. No? What? Yes? Final answer? Yes. It is. You're like, well, it has a denominator. Does it have a denominator? Does it have a variable in the denominator? No. So that would be yes, and that would be no. Then, if it is, so if the expression is a polynomial, identify as monomial, binomial, trinomial. So this one you're already done with because it's not a polynomial. But number 9, monomial, binomial, trinomial. Which one is it? Maggie? Trinomial. So you have to put trinomial. And just for fun, Abby, what's the first term? This is extra that we're just doing on the board. What's the first term here?
X squared.
X squared. Jenna, the second term? Good. Negative x over 2. And Lily Mooney, what's the third term?
1/3.
Yeah. Good. Positive 1/3. So it is a trinomial. Okay. And then, what is the degree for number 9? Nate?
Second.
Yeah, second. So you can just put a 2. That would be your answer. What's the degree of 3? Number 3.
2, 3.
There's no degree. Why? Because it's not a polynomial. So you're done with that one. Number 9, you would have to put extra. Okay. Now I need you to follow the instructions on this next section, and then we'll get to a problem. Yes, ma'am? Okay, good question. Number 7, if you're looking at it, first of all, is it a polynomial? Has a denominator, but there's no variable in the denominator, so good. And then think, how many terms does it have? 1. So monomial. Yeah, because there's no addition going on anywhere there, so there's just one monomial. Good question. I want you to do number 15. Follow the instructions. Yes, sir?
How is number 3 not a polynomial, but like number 13 and 9-2 is, because it has variables.
9-2. Yeah, and so that one isn't simplified yet, and so you have to change it up. But those, so which one were we talking about specifically, so I can point it out? On 13 on 9-2. Yeah, you're going to get everything into the numerator, so then it's a monomial. But that's good questions here. Yes, number 15 on 9-4. Okay, before I even get into the ordering, looking at the original problem, I'm going to call on people to give me what's the first, second, third, and fourth term. Lily, G, what is the first term?
Positive 1/3 x squared x cubed.
Okay, that's my first term. Brian, what's the second term?
4x to the 4th.
Good, positive 4x to the 4th. Carrick, what's the third term?
Negative 2 s 4x squared.
Good, and then Turner, what's the last term? Positive 1/4 x. Okay, whether you need to underline them or you know what the terms are, now you can just rearrange them. Okay, according to the instructions, what should be the first term, Rosalind? 4x to the 4th is the first term, so I'm done with that one. Emery, what's the second term? What should be the second term? That's the second x to the 3rd. Autumn, what's the third term? And the last term here, Harrison?
Positive 1.
Okay. How many of you got that? If you didn't get it, is it because you looked at the S possibly? Or you looked at the whole thing? Remember, in the instructions it says arrange in descending order from the powers of x. So I'm just looking at the x to the 4th, x to the 3rd, x to the 2nd, x to the 1st. Good. I think most of you got it though. 9-5. Number 12. (9-5), number 12. Yes, you're right. Thank you. Is there anything else that's off?
Negative x to the 2nd.
Thank you. Good. I do not want to do this problem unless it's written down right. Anything else? I was just trying to save space here.
It's minus 6 for 2x plus 6.
Thank you. Okay. Yeah, and that's going to be important to write them down carefully because I would have gotten the wrong. I would have done everything nicely and then wrong answer. So good. Thank you guys. All right. What do I have to do in this problem? They're all being added, which you should be very thankful for. So what am I looking for to combine? Yep. Yeah, it's like terms. So I have an x squared term here. I have an x squared term here and an x squared term here. Okay, what's negative 3 plus 5 minus 9? Good, negative 7x squared. Good. And then, do I have any x terms? So let's see, here, here, and here. What's 2x plus negative 7x? Negative 3x. And then I have these, I can call them constants, or I can even call them x to the 0 terms, right? Because don't they have a variable x to the 0 power? So what's negative 5 plus negative 6 plus 3 plus 4? Okay. And it doesn't have to be written in a certain order unless I say it does, which it didn't, so you're good. Maybe we got that. Oh, it's a lot. Okay, any questions? Yeah, be careful on your signs. It was an illustration to make sure you didn't know. I messed up, and thank you for correcting me. Okay, 9 dash, let's do number 9, because that is another variety. Number 9. Hopefully I can write it down the right way. So 9-5, number 9. And this one is different from that last problem because you have a subtraction going on. You remember you can use stay, change, opposite. And what I saw on some quizzes over on the 8th grade, I saw stay, change, stay. So is that how you use it? No. Stay, change, and then get the opposite of each of those terms. So that makes it that problem. Now it's an addition problem. Is there a like term to 4x squared? Yeah, it's negative 7x squared, negative 3x squared. Is there a like term to negative 8y squared? No. Okay. Is there a like term to negative 3z squared? Positive 14z squared, which gives me positive 11z squared, and then that constant is by itself. Oh, wait. Can you combine these two? Wait, they both have squares, but they don't have the same variable. So like terms have the same variable with the same exponents. Okay, good. All right, 9-6. Oh, yes. Number 10. 9-6, number 10. So now you're multiplying a monomial by a polynomial in 9-6. And some of you had questions. Mr. A, okay, yes, you got to use the distributive property. I get that now. But sometimes you don't when you have something inside the parentheses. Why am I allowed to use distributive property here with this polynomial? Because there's something going on in here. What's that something? Addition. If there's addition going on here, you can distribute. If it were just one big multiplication problem, you don't distribute. You just multiply. So in this case, yeah, distribute. What's negative 1/3 x times 9x squared? Negative 3x to the third. So x to the first times x to the second, x to the third. What's negative 1/3 x times x? Negative 1/3 x squared. What's negative 1/3 x times negative 5? Positive 5/3 x. And you can just leave it like that. And that's your answer. You guys okay with this? Okay. 9-7, next page. Only a couple more left. 3 more left, actually. 3. Sorry? Okay, 9-7, I'll have you do number 12. So you have 2 binomials being multiplied, which means you can use FOIL, which is basically the distributive property. Good. It's just a nice acronym that we can use on binomials. So number 12. Okay, Jack, the first term's multiplied. Give me 10x squared, because 2x times 5x, 10x squared. The outside terms are 2x and 2y, which multiply to give me, Autumn, 4. Good, 4xy. The inside terms, which are 3y and 5x, multiply to give me, Emery. Good, xy or yx. And then the last terms, Alex, 3y, 2y, multiply to give me positive 6y squared. Okay, so I end up with 10x squared plus 19xy plus 6y squared. So that's your answer for that one. Good? Okay, just when you thought it got easy, here's this problem for you. Number 18. Be careful with all those signs and multiplying, distributing, and adding like terms if there are any at the end. Number 18. Okay, you guys get this? 25x cubed plus 20x squared plus 31x minus 14. So basically you had to distribute twice. This 5x times these 3 right here, and this negative 2 times these 3 right here. In the last class when I worked it out, when I was first working out, I put a negative 10x squared, and then I looked back up. Wait, it's positive. Would that have affected my answer? Yes. So every sign counts. All right, and then 9-8. See if you can do this one without work. If you totally can't do it without work it out. Number 3. Do it without work. That's impossible, Mr. A. Remember, 9-8 is all about special products. Not special in the bad way, the good way. So it's number 3 on 9-8. And if you don't know how to do it the long way, it's okay. Okay, do you guys remember? This is a square of a difference. Do you guys remember square of a difference? So this is what I did. I did what's q squared? Q squared. What's negative 4h squared? Positive 16h squared. And then I multiply these two together, and then I double it. So it's q times negative 4h, negative 4hq, or qh, doubled, negative 8qh. Done. Or, what you really need to know is what does q minus 4h squared mean in multiplication? Q minus 4h times q minus 4h. That's what it means. Then you can use your FOIL and you still come up with that. How many of you did the FOIL method? Good. That's going to get it right for you. How many of you did it the short way? Oh, nice. I'm not going to make you work these problems out, but number 2 on 9-8, what is that? Don't work it out. Just what is it? It's a, what do we call it? It's a special name. It's a, yes, it is that whatchamacallit, which is what do you call it? Squares. Difference of squares. Number 1 is a square of a, sorry, number 1, square of a sum. So,
Would you still work it out? Could you still work that out using FOIL?
you could do t plus 7 times t plus 7. Or you could do t squared and then plus 49, 7 times 2. 2, you could use FOIL, yes. Anytime you have two binomials multiplied together, no matter what, FOIL is going to be accurate. Okay, your homework tonight. Let's see how you guys take it. Let's see the eyes. Can I see them? Wow, no complaining. Oh man, my secret's out. 45 to 71 odd, and that's pages 551 to 552. You can go ahead and get started. Cool. Yes.